Hello everyone, welcome to Psycouple official YouTube channel. In this video, we are going to learn bandgap energy calculation using Tauc plot in Origin. That is bandgap energy calculation using Tauc plot in Origin. What is Tauc equation? Tauc equation is given as alpha h nu exponent gamma is equal to A into h nu minus Eg, where alpha is the absorption coefficient, h is the Planck constant, nu is the photon's frequency, A is the proportionality constant, Eg is the bandgap of the material, and the gamma represents the nature of electronic transition. That is, if gamma is equal to 2, that means it is direct allowed transition. If gamma is equal to 1 by 2, it is indirect allowed transition. Gamma is equal to 2 by 3 means it is direct forbidden transition. Gamma is equal to 1 by 3, that means indirect forbidden transition. Basic absorption process typically dominates the allowed transition. That is, gamma is equal to 2 or gamma is equal to 1 by 2. Thus, the plot of alpha h nu raised to gamma versus h nu is a test for gamma is equal to 2 or 1 by 2 to find out the best fit, and thus identifies the correct transition type, whether it is direct transition or indirect transition, or in other ways direct bandgap or indirect bandgap. If we compare the Tauc equation with the standard form of a straight line, that is Tauc equation alpha h nu raised to gamma is equal to A into h nu minus Eg, and the straight line standard form is y is equal to mx plus c. Putting the y-axis is equal to 0 will bring us to the x-axis. Next, solving for the energy, the extrapolation of the linear region of the plot onto the x-axis gives the bandgap energy. The absorption coefficient alpha will obtain from Beer-Lambert's law. A detailed video regarding this Beer-Lambert's law is already uploaded in our channel. If you are watching our channel for the first time, please go and watch that video. According to Beer-Lambert's law, transmitted light is exponentially proportional to minus alpha x into intensity of incident light I0. I0 is the intensity of incident light, I1 is the intensity of transmitted light, the path length is the width of the cuvette, and normally it is 1 centimeter, and alpha is the absorption coefficient. Transmittance T is equal to I1 by I0. Or in other way, I1 by I0 is equal to e raised to minus alpha into L. L is the path length. Converting it into log, that is log of I1 by I0 is equal to log of e raised to minus alpha L. That is equal to log of I1 by I0 is equal to minus alpha L into log E. We know the value of log E, that is 0.4343. So substituting the value of log E into the equation will result log I1 by I0 is equal to minus alpha L into 0.4343. And then keeping in mind that log of xy is equal to minus log of y by x. So here log I0 by I1 is equal to A is equal to alpha L into 0.4343. Thus alpha is equal to 2.302 into A divided by L. Normally L is equal to 1 centimeter. So alpha is equal to 2.302 into absorbance in centimeter raised to minus 1. So the absorption coefficient alpha is equal to 2.302 into absorbance. This absorbance we will get directly from the UV-Vis absorption spectroscopy. After that, we need to convert units. The incident energy E is equal to h nu. Substitute the values. E is equal to h, the value of Planck constant is 6.625 into 10 raised to minus 34 joule second into 2.998 into 10 raised to 8 meter per second and then convert joule into electron volt because we need band gap in the unit of electron volt. 1 electron volt is equal to 1.602 into 10 raised to minus 19 joule. Thus the equation become 1.986 into 10 raised to minus 25 joule second into 2.998 into 10 raised to 8 EVM divided by lambda m into 1.602 into 10 raised to. Then next step is change the lambda in meter unit to nanometer unit. Thus energy E is equal to 1240 EV divided by lambda in nanometer. Absorption spectra will give the wavelength value in nanometer. Thus the energy can be calculated by using this equation 1240 EV divided by lambda in nanometer. Next, we can check how we can apply this Tauc equation to find out the band gap energy in origin. First, copy the absorbance data into a workbook. X is the wavelength in nanometer and y-axis is the absorbance. First, find out alpha. For that, add one more column to the workbook. Absorbance coefficient or absorption coefficient unit is centimeter raised to minus 1. And absorption coefficient alpha is equal to 2.302 into absorbance, which is B value. Add another column to calculate the energy h nu in unit of electron volt. That is energy E is equal to 1240 divided by lambda, unit is electron volt. That is 1240 divided by the wavelength. Next, add one more column to find out alpha h nu raised to 1 by 2 and another column to find out alpha h nu raised to 2. Unit for both of them is electron volt centimeter raised to minus 1 whole raised to 1 by 2 or electron volt centimeter raised to minus 1 whole raised to 2. Next, E of y is equal to C into D raised to 1 by 2 and Fy is equal to C into D raised to 2. Plot first this D and E and then D and F. Before that, make D as X. By comparing these two graphs, this one shows the best fit for the linear region extrapolation. That is 2 or 1 by 2. Which one is more suitable? So this is more suitable and focus this graph. Then draw a straight line onto the x-axis or draw a tangent to the graph and extrapolate to x-axis. Check the x-intercept value and this is the band gap energy in electron volt. Next, modify the appearance of the graph by changing the color, line thickness, etc. The x-axis name is energy in electron volt and the y-axis is alpha h nu raised to 1 by 2, unit is centimeter raised to minus 1 electron volt. Also, you can modify the color, line thickness, etc. of the tangent. If you like the video, please share and subscribe our channel. Thank you for watching.